Hello, today we're going to we're going to do Module 3, I'm getting ahead of myself, Lesson 17. We're going to identify patterns in multiplication and division facts using the multiplication table. So I need you to pull out your homework sheet as well as your paper that will give you the 10 free points, because you're going to be needing your homework sheets as well. Okay, before we start with our homework sheets, I would like to do an application problem. Pen and pencil. Henry's garden has 9 rows of squash plants. Each row has 8 squash plants. There is also 1 row with 8 watermelon plants. How many squash and watermelon plants does Henry have in all? Now you can do this with multiplication statements or number sentences, or you can use an array. So let's do an array. So 9 rows of 8. So I didn't pick up my pencil. Okay. 1, 2, 3, 4, 6, 7, 8, 9. Now finish your array. Make sure you line up your dots best as you can. This is 4. 5, 6, 7, 2, 3, 4, 5, 6, 7, 8. So 9 rows with 8 squash plants. Each one of these dots would be a squash plant in our garden. And then we had all of this right here. Whoops. The squash. Okay. And then we had 1 row of 8 watermelon plants. 2, 3, 4, 5, 6, 7, 8. And this one right here would be watermelon. Melon. Okay. Now, what would this be as a multiplication sentence? 9 rows of 8. Okay? Now, we need to figure out what this is. If you don't happen to just know what that is, then let's do the commutative property and use one of our tricks. So I'm going to do, that's the same as 8 times 9, right? I would just have to turn my paper over so my array is a different direction, right? Okay, now, when I did this, I have that trick, remember? This is 1 less than the 10th spot, so what is that? 1 less than 8 is 7. And 10 take away 8 is 2. So 9 times 8 is 72. We need a math sentence for this, number sentence for this. This is 1 row of 8, okay, which would be 8 plants. Now, how many plants does she have all together? We need to add these up. 72 plus 8. 8 and 2 is 10. We have 80. Alright. Oh, he has 80 plants in all. Period. Make sure it starts with a capital, and it's in a period, and it's a true sentence. Now, if you decided not to do the array, you could have done this another way. Knowing that this is a multiplication sentence, you could do 9 times 8, and you could do your 1 times 8. 9 times 8 is 72. We know 1 times 8 is 8. Then add them up. What do we have? The same thing. And then you would write your statement. Henry has 80 plants in all. Okay. Either way is correct. Now, before we can move on to our homework, we need to talk about some math problems. So let's use this. 8 times 9, 72. Before we start, let's talk about some things. Let's talk about some words. Okay? So, we need to know what a factor is today. We need to know what a product is. And we need to know what a sum is. Okay. Now, these are all examples of each one of these 3, so we just have to figure out which part is which. A factor is the two numbers that are multiplied together in a multiplication sentence, or two numbers that can be taken out in a multiplication sentence. Okay, so for instance, a factor is two numbers, or just not, it doesn't even have to be two, but it's the numbers multiplied. Okay, so which one is the numbers that are multiplied in this statement, in this number sentence? It's the 8 and the 9. Okay, they get F's because these are our factors. Now what's our product? The product is a fancy way of saying an answer for a spell it correctly, multiplication problem. So, which one is my product? Which one's the answer? This is the answer. I'm putting a box around this, and it gets P. This is our product. Sum is a fancy word for saying an answer for an, oops. Oh my goodness. Pointer. Push the button on the pencil. That's what happened. One more. Let's get it going. Here we go. Try again. Alright. Now make sure I have a pencil. Okay, please ignore this line. That's what happened when I tried to click. Okay, answer for a sum is the answer for an addition problem. Okay. So, right here, put ellipse around this one would be our sum. I'm going to put an S over here. What was that? That was 80. 80 is our sum. 72 is our product. And these are the factors. Okay? So, now we know what that is. Let me just test you. Let's do sometimes 9 is 63. Okay, and we could have 63 plus 7. Okay, because I have to regroup my 10. Okay, which one's the factor? Which ones are factors? I'm trying to change my color here. Let's see if it'll let me. There we are. Factors are going to be green. This is a factor, and this is a factor. Okay? Now we need a product. Products are going to be red. What is a product? The answer to a multiplication sentence is a product. Okay? And which would the sum be? Try to get it to go. Let's do it blue. Sum is going to be the answer to an addition sentence. Okay? Alright. Now, look at your homework, and if you notice, you have two tables on the first page. Okay? Now, you're going to fill in each of those tables with a multiplication sentence. So let me draw a piece of the table here, and let's talk about this table. Some of you may remember these tables, remember how to do it. Others, they may find this confusing, so let's just go over it. Okay. These boxes. Oh. Where is it? A little crazy here in my drawing. Thank you for your patience. Okay, now I'm going to change my color back to black. It will let me? There we go. Okay, now up at the top we have times. Then we have 1, 2, that looks like a Y. 3, 4, 5. Then we have 1, 2, 3, 4. Now if you'll notice, this is like the top left corner of that chart. Now this is how you do it. 1 times 1 is 1. This goes here. And let's go across. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 1 times 5 is 5. Now we do it up here. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. Now let's do 3's. 3 times 1 is 3. 3 times 2 is 6. 3 times 3, 9. 3 times 4, 12. 3 times 5, 15. Now we do 4's. 4 times 1 is 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. 4 times 5, 20. Okay, so you got the top corner already done. Now, in 1CU, it says color rows and columns with even factors yellow. So let's look at this. Let me find my highlighter. It says yellow. Okay, if it has an even factor, I can color it yellow. And I'm looking for rows and columns. Rows go across, columns go up and down. Now, do these have all evens? I'm looking for even numbers. What's an even number? It means you can split it in half. This one has an odd number, but this one's even. Nope, this one won't work. Okay, what about this? Are these all even? Oh, these are all even, so we would color these yellow. The whole row. Okay, now, are these evens? No, there's a couple even numbers, but the whole thing's not even. What about this? Is this even? This one's even. So we color this row. Alright, now let's do our columns. Look at these numbers. Are they even? Not all of them, only some of them. What about this one? This one's even. Alright. So color it in. Okay, what about this one? Oh, there's some evens, but some odds, so we can't do it only if it has all evens. Does this one have all evens? This one does. Okay. Now, what about this one? Some, but not all, so we can't do that. Okay. Now, it says, what do you notice about the factors and products that are left unshaded? So look at the ones that are not colored in at all. What do you notice about them? What are they? They're all, what? Odd. Okay, do you know what I want? I would like a complete sentence. All of the unshaded factors. Now, why are we calling these a factors? Because these are the numbers we multiply together, aren't we? Are odd. Every one of them is an odd number, isn't it? 15, is that odd? Yep. 5, is that odd? 9, 3, all odd numbers. Okay. Now, we've now done the top part of the front of the page. I want you to look at something else. Okay. Now, it's got these rules. Okay. Now, we need to know what an odd times an odd is. We need to know what an even times an even is. And we need to know what an even times an odd is. These are rules. Alright, well let's see if we can figure out by using an example. So odd times odd. So we can only do odd numbers. So let's say 3 times 5. What is that? It's 15. Okay, what about 1 times 3? Well, that would be 9. Or I mean 3. What about 3 times 3? They're both odd. That would be 9. What about 7 times 3? These are all odd numbers. Odd, 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 odd. If you have two odd factors, what do you get? You always get an odd product. Alright. So if you have an odd times an odd, you get an odd product. Okay. What if you have an even times an even? Actually, you know what? You get odd. Okay, what if you had an even times even, like 2 times 4? What do you get? Or 2 times 2? You get 4. What if you do 2 times 4? You get 8. Okay, what about 4 times 8? You get 32. One more, how about 6 times 2? What do you get? 12. Okay, so if the factors are both even, what's your answer? Your answer is going to be even. Okay, so you would have an even product. Okay, now but what happens if you have an even times an odd number? So what if you have a 2 times a 3? What do you get? You get a 6. Okay, what if you have a 4 times a 5? It's a 20. So even odd. How about 6 times a 6? Well, that's 36. So, oh, no, that won't work. That won't work for our pattern. Because we have to have an odd number. How about 6 times 7? Is that 42? Okay. How about 8 times 9? That was 72. What do you get? If you have an even times an odd, what do you always get? You always get even. You will always get an even product. Alright, we are done with the first page. Now, if you look at D in the back, it's asking 7 times 6 equals 5 times 6 plus 2 times 6. This is a review. Why is that a review? Because we've already done this. What is the thing that we've done? We've taken apart something, haven't we? We really had 5 plus 2, and we multiplied it by 6. We just found another way of rewriting this, right? Alright, so this one would be 7 times 6. Okay, so how is it shown on the table? What's the answer? It's 42. How is it shown on the table? Is it odd or is it even? Okay, I want you to figure that out and then explain it to me in words. Okay, how did it get to be the way it is? How did 5 times 6 plus 2 times 6 get to be 7 times 6? What happened? See, we just showed you. They use the distributive property, so let's take it away. Let's go backwards. And now we have the 5 plus the 2, and they're both times 6. Okay? Now, number E is very similar. They're taking it apart, aren't they? Okay, now if you look at number 2, in the lesson we found that n times n is the sum of the first odd numbers. Okay, you're going to learn this tomorrow. So even though it says you've already learned it, you're going to learn it tomorrow. Okay? Now it says, use this pattern to find the value for n for each equation below. The first one's done for us. So they had 1 plus 3 plus 5 equals n times n. Okay, now this means they have to be the same number, right? Okay, so what do we have? 4 plus 5, that's 9. So what is the number that's the same that we can multiply it by to get this product? Now, what we used to do in addition is we used to call them doubles. I kind of can't call them doubles here, but it's kind of like that only with multiplication. Okay, so if I have a 3 times what gives me 9? That's a 3 times a 3, right? Okay, let's do this one. 1 plus 3 plus 5 plus 7. What does that equal? N times n. Okay, let's add it up. 4, 9, 9, and 7 is 16. Okay, what times what has to be the same number would give us 16? That's right, it would be a 4, right? 4 times 4, because they had the same number. Okay, let's do one more, and then I'm going to leave the last couple to you. Let's do the very last one. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 19 plus 21 equals times n. Okay, what do we have? We have 4, and 5 is 9, 16, 16 plus 9. I'm just going to do it up here real quick. Do your plus sign so you don't forget. 15. So this one's 25. 25 plus 11, what is that? 36. Okay, this is 36. Plus another 13. So 6 and 3 is 9. So I add 1 plus 4. So this one's 49. And then we're going to add 15 to that. So that's 14. 64. Okay. I'm going to have to come back up here. I'm running out of space in my column. So 64 plus 19. Alright, I want this, and I want this. There we go. Awesome. Okay, we weren't done here. I was thinking. Give it a minute. Okay, now 4 plus 9 is 13. Oh! Over here. Oh, pencil. There we go, pencil. There we go. 13, 6, 7, 8. So that'd be 83. Okay, now we're going to put that here. 83 plus 21. So add the 21 to it. Okay, 3 and 1 is, oh! And it's black. And we're back here again. Whoops. Sometimes computers just go a little nuts, don't they? No big deal. We just take care of it. Alright, I'll try a different way. There! I like it. No, I don't like that one. Come on, computer. There's one out. Come on. There we go. Okay, pencil. Should we have pencil? Okay, now let's finish this. I can't wait to find out what it is. This is a 4, and this would be a 10. Oh my. So this is 104. So we got to find out what 104 is. It has the same number that has 2 of it. So, here we go. What number could it be? I'm thinking it's 52. Let's see what 52 plus 52 is. 4, 10. Sure enough. Why did I choose 52? Well, because I know 50 plus 50 is 100. And 2 plus 2 is 4. So I just add them together. That's how I got that. Alright. Now, you've got to finish the last little bits of it, and then you'll be all done for tonight. Now tomorrow we're going to be doing another table, and we're going to be doing one other pattern as well. Alright, have a good night.